Okay, we're going to solve every quadratic equation, because every quadratic equation can be simplified down to this format. ax squared plus bx plus c equals to 0. And so we're going to solve for x. Now the way to do that is to use the completing the square method. And your impulse may be to say, oh, I don't want to see this. Well, if you want to get good at this subject, if you want to do well in this course, then you need to pay attention to these things, because and this is a little bit abstract to follow, but it's very good for you to look at this and concentrate on, try to follow it, because we are trying to stretch your mind here, make you a better thinker, and the better you are thinking, the easier this course is going to be, and the better you're going to be. So bear with me on this, because every college algebra student should see and understand the derivation of the quadratic formula. Now, from a historical context, people have been solving quadratic equations since ancient Babylonian times. This is many thousands of years ago. And so there were different techniques which evolved over many centuries. And but as far as a general formula, I can't say when that came up, when people finally were able to solve all of them. But I'm assuming it's roughly 1,000 years old, maybe a little bit older than that. And so we're doing old math, but it was great thinking here. And again, try to concentrate on following the steps here. It's very good for you to try to understand this. All right. In completing the square, I mentioned that the first step was to make the leading coefficient 1. And as long as a is not 1, then I can only do that by dividing both sides by a. So when I do that, the a's cancel. I have x squared plus b over a times x plus c over a, and 0 over a is going to be 0. Now, one little disclaimer here: I didn't say that a had to be could not be 0. If a was equal to 0, you wouldn't have a quadratic. You would have a linear equation. So this all assumes that a is not equal to 0. Otherwise, you have this 0 over 0 problem. All right, our next step in completing the square was to transfer this term to the right side. So I have x squared plus b over a times x. I'm going to put a space, equals to negative c over a. And now comes that unusual step in completing the square. And I must admit, it's not intuitive at all. It is kind of a strange step to take. But we're going to take half of the coefficient of x. In other words, we're going to take half of b over a. And what is half of b over a? That would be b over 2a. Because when you take half of something, you're doubling the denominator. So I'm going to square this term and add it to both sides. And we have this. Now it turns out this whole left side, and you can verify this without too much trouble, the whole left side is going to factor as a perfect square. It's going to be x plus b over 2a quantity squared. And again, you can multiply this out, multiply this by itself, and you would get the whole left side here. It would work. On the right side, I'm going to get minus c over a plus b squared over 4a squared. So I went ahead and squared that out. And I'm going to do something else. I want to combine these fractions together. Now, to combine them, I need a common denominator. So this has a 4, the left side doesn't, so I'm going to introduce a 4 here. And this has a, and this has a squared, so to get a squared, I need to multiply by a. So I end up with, on the left side, x plus b over 2a squared equals to, and here I've got the common denominator now, 4a squared. And the way I'm going to combine these, I'm going to put the positive term and then the negative term. So it's going to be b squared and then minus, and this is 4ac. So if you're familiar with the quadratic formula, you're going to start to see it take shape here. You may start to recognize parts of the quadratic formula. All right, well, I need to do a little bit of erasing to finish this up. And but we have, completing the square process served its purpose, which is to create or manipulate the equation into a form where you can use the square root method. Now, again, the square root method, you have a variable term squared. So I have x. This term contains a variable and it's squared. And the right side is a constant number because a, b, and c represent numbers, just plain old numbers that you can plug in. They're not variables. So this is a constant, as ugly as it looks. So I can take the square root of both sides, and as always, when you do that, you need to toss in the plus or minus symbol to count for all the answers. And we're almost there, because this now simplifies the left side down to x plus b over 2a, and the right side becomes, on top I have the square root of b squared minus 4ac, and down below we take the square root of 4a squared, that's 2 times a, and we're done with that. And what's nice here is I have these two fractions have the same common denominator, so I'm going to subtract this fraction in order to transfer it to the right side of the equation. So by subtracting b over 2a, it'll become a minus b over 2a, and those two fractions will combine. So I end up with x equals to negative b minus, whoops, I forgot something important here. My plus or minus symbol. Don't forget that. So minus b plus or minus the square root of b squared minus 4ac, and everything is divided by my common denominator of 2a. So here we go. This is the quadratic formula. So, and probably most of you have seen that before. Some of you may actually have it memorized. I think it's a formula worth memorizing. There aren't very many formulas in math worth memorizing. Area of a circle, circumference of a circle, area of a triangle, that's worth memorizing. This is worth memorizing also, the quadratic formula. So the quadratic formula is a process that will solve any quadratic equation. And so it's sort of like our fail-stop method, or foolproof method of solving any quadratic equation. If we can't factor it, if using the square root method is not immediately available to us, then normally you just use the quadratic formula. So there it is. There's the derivation. Let me just take a quick aside. And what if you wanted to solve something larger? For example, ax cubed plus bx squared plus cx plus d equals to 0. That's called a cubic equation. It's a third degree equation. And I've got it written out in a general form. You might wonder, well, is there a formula that solves this one? And in fact, there is a formula. And would it involve completing the cube? Well, kind of. It's a pretty rough one to solve. This was first solved in the 1500s, and they also solved, in the same time period, fourth degree polynomial equations. So there are formulas for third and fourth degree polynomial equations, like the quadratic formula, except these formulas are really bad. I mean, they're big, ugly, and very unwieldy. And in fact, nowadays no one uses them. They're too complicated. We use approximation techniques if we really have to solve these things. And so there is actually, if you go to the 5th degree or higher, degree 5 or higher, there is no formula possible. It's not that we haven't discovered, it's that it's impossible to get one. And that's a pretty profound result in mathematics that came about in the 1820s. And I may talk about it in a later video in a little more depth. So long story to all that. But anyway, so as far as formulas for polynomial equations, to be practical, we stop at the quadratic formula, and that's good enough. So again, memorize this, and you know, it's very easy to memorize this. All you have to do is write it down each time you use it, and after about 8 or 10 times, you'll have it memorized. So the remaining part of this section is in applying the quadratic formula to various kinds of problems.